Math Analyzers. Welcome to your Chapter 7, Lesson 5 notes, all about the change of base formula. Okay, so last time we looked at logs, we just got introduced to them. Another way of writing our exponents. Okay, so exponents can be converted into logarithmic form, and logs can be converted into exponential form, back and forth. Okay, and where the pieces go is what's so important to remember. Okay, so this is 2 to the third power equals 8. So there's an exponential equation, right? Okay, if I want to convert this into logarithmic form, the base of the exponent is the base on the log. That's that little number, okay, that little index number here. The answer to the exponent is the number inside the log, the actual physically bigger number in the log. And the answer to a log, to evaluate a log, is to ask 2 to what power is 8? That would be 2 to the third power. Okay? So we have to make sure we remember those pieces. Also, two really common uses of logs are log base 10 and log base e. Log base e is the natural log, and of course, using Euler's number as your base. So instead of writing out log base e, we write ln, and that's it. We know that that means log base e. Okay, and again, I mentioned this before, but if you don't know that and you need that reminder that your base is e, just write it out this way. When I just write the word log and don't put a base on it, it's assumed it's base 10. Kind of like when it's a square root and you're just taking a square root, it's assumed the index is 2 and you're just taking a square root. It's the same with logs. If I don't write the base, it's base 10 because that's the most commonly used base on our logs. All right. So, well, if base 10 is the most commonly used, and so far I haven't actually showed you much of that, let's convert things into base 10. We have this thing called the logarithmic change of base formula that takes our log with any base with its answer present and converts that into having base 10 for both. Because remember, the button on your graphing calculator, this log button right here, let me pull this guy out, this log button right here, oops, that wasn't what I wanted to press, is assuming base 10. Okay. Oh, hello. So now let's do that. Let's use the change of base formula. Log b, log to the base b of x is equal to log of x over log of b. So let's say I have log base 2 to the 64. Remember, the question being asked is 2 to the what power is 64? This one actually does convert, so that's good. It converts into it having an integer exponent, but a lot of them won't. And that's actually what we're going to see a lot more of. That's why we use logs, is what if our exponent isn't a nice, easy integer or a fraction like 1/2? What then? That's how we use logs. Okay, how do you get from log base 2 to 17? 2 to the what power is 17? Well, you're not going to be able to do that in your head. We use this conversion to figure that out. Okay, and I'm using one that you know to show you that this works. Okay, so I'm going to use this one, like I said, use one that you know to show you that this works. And this is how we do this in our graphing calculator. You type log, and you put the physically bigger number that's in your logarithm here. And then you close the parenthesis. Then you divide it by the log base 10 of the base on your log, and you close that parenthesis. So you're taking the log of the answer and dividing it by the log of the base. Both are now in base 10, so you can just use the log button rather than worry about your bases. And of course, we do know that 2 to the 6th power is 64. That's how we know that conversion works. Now, I just used the example when I said it out loud. I just said, but what if we had log base 2 to 17? Because off the top of my head, I certainly do not know 2 to the what power, equals 17. Because it's not an integer and it's not a 1/2. Okay? It's not going to be a nice, easy fraction or integer. Okay? Instead, it's going to be an irrational number, a non-repeating, non-terminating decimal. So let's figure it out. You do log of 17, end parenthesis, divided by log of 2, your base, end parenthesis. Kind of makes sense, right? Because 2 to the 4th power is 16. Oh, look at that. So we're just a little bit above 4 as a number. And again, this is a non-repeating, non-terminating decimal, so this is an approximation. When you get these, okay, so when I get this as my answer, we typically round to the nearest 10,000th for decimal places. Okay, so 4.0875. Round that last one up. Okay. So again, most of the time when you're using the log change of base formula, you're going to be having these non-integer answers. We're going to start by evaluating ones that will have integer answers just so we can easily test to make sure we're doing this correctly. Okay, so that's how we're going to start. Like these from yesterday. We did look at these in lesson 4. Okay, so we've seen these. And again, this is exactly what we did yesterday at the very end. 4 to the what power is 4,096? Well, we had figured out that's 4 to the 6th power. And again, I can test that right here, right? Me and my cursor are not getting along today. 4 to the 6th power is 4,096, right? 2 to the what power is 32. Well, that's 2 to the 5th power. ln1 is 0 or 2 pi I, right? We knew that those were both potential answers there. I'll write it down. 4, 2 pi I. I'll show you that in a sec. 4 to the what power is 1/16. Well, I know 4 to the 2nd is 16. So 4 to the negative 2nd is 1/16. Now, the way we're going to do these problems is we're going to write down the conversion into change of base and then type it in our graphing calculator to make sure we're correct. So I want to see you doing the conversion if I ask you to use change of base formula. So you have to write it out. Log base 10, I don't have to write it, of 4,096 divided by log base 10 of 4. And again, the whole point is I don't have to write that 10 as my base when I just write the word log. And I can just say log instead of saying log base 10. Now, of course, because I'm just teaching you this and we're just starting, that's why I was saying log base 10. Okay. Let me pull this out. So that is a little bit bigger and you can see my screen. So log of 4,096 divided by log of 4 should equal 6 from above, right? That's where those match up. Okay. Log base 2 of 32 converts into log 32 divided by log 2. Okay. The written bigger number divided by the written smaller number, right? So I don't like to say as size-wise as far as the amount the number is worth. It's how they're written in the log. The little index versus the big answer that's in your log, right? So, of course, typing this in log 32 in parentheses divided by log 2 end parentheses matches from above. So far, so good. I didn't use this one in here, but that's just because I just want to show you real quick why I didn't use it. You can just type ln1. It's not necessarily a conversion. That was just kind of thrown in there because, right? So this one, we're going to convert into log 125 divided by log 5. And of course, 5 to the third is 125. So let's type this in just to make sure we get this back and forth. And again, practice typing this in because that's what gets that change of base formula rolling in your head, really stuck in your head. Okay. And 4 to the what power is 1/16? Well, you know what? I don't need to know off the top of my head anymore because now I can just write log of 1/16 divided by log of 4. Okay. So that's all I have to do. So I can just do log of 1/16. And this is why it's important to close that parenthesis and then do your division of log of 4 to get -2. Okay, let that soak for a sec. Make sure we're all good there. Okay. What if? Now we're going to get crazy. What if you got a log and an exponent, right? So now we're not only thinking about converting logs into exponents and exponents into logs and back and forth. Now we got a log in our exponent too. Actually, this is kind of cool. This is really cool. If the base that's being raised to the log has the same base in the log, they cancel. This is really neat how this works. Let's think about it, okay, using this example that I start with, and then we'll actually do it, and we'll do that change, okay? So log base 5 to the 25. I'm just going to take that out of this first and look at it, okay? Log base 5 to 25 is 2. Yep. Okay. So that means I'm going to substitute in 2 where there was a log base 5 to the 25. And what is 5 squared? It's 25. This and this were the same base. What could I have done instead? Just canceled that, brought down the 25. So 11 and log base 11 cancel. What's the answer to simplify this? 121. 3 and log base 3 cancel. What's the answer to simplify this? 81. Okay. And again, it's because log base 3 to 81 is asking me 3 to the what power equals 81? Well, it's 4. So I substitute in 4 for log base 381. So now it's 3 to the 4th power. What did we just say 3 to the 4th power was? 81. Why go through all that back and forth when you can just do that cancel? Okay? That's what's really cool when we start to see that. Okay? And again, make sure you see that. Make sure you understand what I've done. I've just skipped a step. I've done the substitution and skipped the step and realized, oh, this works every time. So I can just do the cancel as long as the bases are the same. So as long as the bases are the same, you can do that. All right? Bases are the same. Here, I'll zoom in because it's tougher to see. I know you have this on your paper, but still, it's tougher to see. Bases are the same. Cancel them. Your answer is 216. Okay? Bases are not the same. I'll get to this in a sec. Bases are the same. Cancel. Your answer is 15. Why did I say 18? Bases are the same. Your answer is 40. Oh, crap. There's 3 of them where the bases aren't the same, right? Okay. Make the same base. Make the same base. This goes back to lesson 3. Make the same base. How can I get a base of 3 out of 9? Okay, well, that would be 3 squared, but I already had this exponent up here, right? So I've just converted 9 into 3 squared. Well, the 3 and the log base 3 can now cancel, but this 2 here, where I use the conversion, is now actually the exponent on this number. So this is really 10 squared. And what's 10 squared? 100. Let's do that again. Okay, how can I make 8 a base of 2 to match this log? That would be 2 cubed, right? But I already had this log base 2 to 5 right here. Well, now the 2's cancel, but this 3 needs to be the exponent on 5. So this is really 5 cubed. What's 5 times 5 times 5? 125, as we saw earlier. 16 can be 4 to the what power? That can be brought down 4 to the what power? 4 squared, right? But you've already got this thing here. So just rewrite it. The 4's as the bases are gone, but this 2 right here needs to now be the exponent on 8. 8 squared is 64. Okay? And just a by the way, zoom out. Just a by the way, you can test that in your graphing calculator. Okay? So 16 raised to, oh, I've just got to convert it. Log, let's see, let's do front parenthesis, log base 8. And then divided by log of 4. And then one big end parenthesis here, right? Worked. So you can always test my theory because it works. Theories are the thing that have been proven to be correct, right? There you go. I used change base formula just to check that guy, right? I was able to convert my base into an exponent that matches so my bases can cancel. But what we're going to learn in the next lesson of the chapter is what this that I just did, this number out in front of a log, how that is actually an exponent on this answer. So now it's all going to come together. Okay. Guys, again, practice that change of base. Get that in your head, this change of base formula, going back and forth. Okay? Math analyzers, I really look forward to working with you on this one. This is your change of base formula. So this is chapter 7, lesson 5. Please ask me if you have any questions. Always happy to help you with this. Good luck. Write out that change of base so you get it in your head. I'll be seeing you guys. Bye.